And we're on. 5010 work, compilation, Shm worksheet, masking. All right. So we did do some part of this question. So I'm gonna look for problems. I intend not to take questions from you one by one. Rather, I'd go question by question. So if you have any problem in a specific question, you respond. আমাদের লাস্ট কত পর্যন্ত করা হয়েছিল কি একটু আমাকে হেল্প করো। We did this one. I remember this very well. We did this one. Did we finish this worksheet by any chance? No.
This question by question.
Yes, sir. Finish করেছি। Problem আছে।
Problem বলো।
Sir, 2B না এটা তো সলভ হয়েছে। দাঁড়ান আমি একটু দেখি।
স্যার 1 বিটা একবার রিপিট করতে পারবেন?
না repetition লাগলে YouTube lecture থেকে দেখো, and then if you have further question PM me. I'll explain you personally.
Okay, sir.
Not taking everyone's time.
Number C2.
কত?
6C2.
Okay. Number 6 is the question where we are also having a oscillation case. We have filled up a tube with sand, and we're gonna make it oscillation in a water. Very good. Let's have a look at the question. A tube closed at one end has a uniform area of cross section. The tube contains some sand, so that the tube floats upright in a liquid as shown in figure 3.1. When the tube is at rest, the depth d of immersion of the base of the tube is 16 centimeter. The tube is displaced vertically and then released. The variation time t of the depth of d of the base of the tube is shown in figure 3.2. So this bottom that is undergoing this amount of oscillation. So you can see this is a graph that goes 15, 16, 17 like that. D in this case represents depth from the open surface. So first the depth was 15.5 centimeter at t equals to 0, and then the depth was increasing, and the lowest point of the highest depth was how much? How much is this value?
Sir, 16.5.
16.5. So that way you should visualize this thing, that it was lifted up. It says that the tube is vertically, the tube is displaced vertically and then released. So displaced vertically in this case, that we did not push the liquid, we did not essentially push the tube down. We lifted up the tube, lifted up the tube from its equilibrium position or rest position by half centimeter. You can see that if for this oscillation curve, 60 centimeter is your equilibrium line. So
Yes, sir.
the rest position was supposed to be 60 centimeter, but it started this motion from a depth of 15.5 centimeter, which means that we did lift it up by half centimeter, then we let go, and then it was oscillating within half centimeter amplitude as shown in the figure. As for the figure, as we can see, a couple of characteristics that we have, we do not have any reduction of amplitude, so you don't essentially say that this oscillation is damped anyway, so there is no energy loss. So let's go for the parts. Excuse me. All right. I'm sorry.
Are you all right, sir?
Okay. So problem কোনটাতে বলছো B তে?
না স্যার CA2
The liquid in B is now cooled so that although the density is unchanged, there is friction between the liquid and the tube as it oscillates. Having been displaced, the tube completes approximately 10 oscillation before coming to rest. On figure 3.2, draw a line to show the variation with time t of the depth d for the first 2.5 seconds of the motion. So you are expected to show some damping effect over here. So the way we actually discuss the damping graph is that whenever you have damping, in this case, this is essentially what is it called? Mild damping, মানে হচ্ছে আর কি under damping, because it does not it is not over damping, neither it is critical damping. So it takes 10 oscillation to reduce the energy altogether. So you can draw that curve in a fashion like this, or I believe.
স্যার কোশ্চেনটা টাইম নিয়ে কি কি বললো ওই পার্টটাও বুঝতে পারি নাই মানে কোশ্চেনটা
up to 2.5 সেকেন্ড, মানে হচ্ছে এই টাইম পর্যন্ত তোমাকে at least গ্রাফ রাখতে বলছে।
আচ্ছা আর স্যার 10 কি বললো অসিলেশন না কি জানি একটা
মানে হচ্ছে এখান থেকে এটুকু পর্যন্ত হচ্ছে একটা মানে from this point to this point we have one oscillation, right?
ইয়েস
One
স্যার
complete oscillation. This when the friction is introduced into the oscillating system because of the temperature drop of the liquid, which introduces the friction. So in that case, the object comes to rest, or it loses all of its amplitude after 10 oscillation. Now, if you have a look, how many oscillations do we have up to 2.5 seconds? So 1, 2,
Three.
3,
3.5
3 plus something.
হ্যাঁ
Okay, so we up till now, up till this point, the oscillation would not be zero, but it would be definitely becoming less. Now, here's a catch. The catch is that I'm not sure what the mark scheme contains, but I'll tell you what how I would draw this graph. Whenever the object is over here, it would have a, I mean, initially it would have a bigger amplitude, and as you go further down the line, your amplitude is going to become smaller. And if you consider the maximum equation is given by v equals to plus minus omega a. Remember? Sorry, maximum speed. Maximum speed is given by v equals to plus minus omega a. So as you slowly obtain less and less amplitude of the oscillation, your speed of the maximum speed of the particle is slowly also going to become smaller, obviously because the kinetic energy is being wasted because due to friction. So when you have the high speed, you would lose the most amount of energy. The less your speed becomes, your reduction amount is also going to become smaller. So what I mean is that we are going to keep the period exactly same, because in this case the mass of the oscillating system did not change at all. So the time period of the oscillation would remain exactly same. However, we'll be losing the amplitude, but you have to show largest loss of amplitude at the beginning. Then as your speed becomes smaller and smaller and smaller, the magnitude of loss that should become small. So let me explain what I mean by this statement. Let me try and draw this up so that it makes a bit better sense to you. Let's say green may be good.
স্যার এটা যে ওভার ড্যাম্পিং বা ক্রিটিক্যাল ড্যাম্পিং না এটা কি করে বুঝলাম
Critical damping এর concept হচ্ছে the object should start oscillating like that, and it will immediately come to equilibrium position after half an oscillation.
ও আচ্ছা স্যার
And overdamping is the case where the object would go to a certain amplitude and it will not oscillate anymore. It will simply slowly come back to its original position.
আচ্ছা স্যার বুঝতে পেরেছি
Okay. So this graph could look like this. Let's say for this part, I'm showing a reduction of 2 divisions. That's what I'm starting with. Let's assume. So let's say here I'm gonna have a bit of a curve like that, and then so having the cross points is exactly the same, and then so I have shown over here 2 divisions. It is perfectly 2 division hoy nai, so I'm gonna show over here a little bit less than 2 divisions. Wait. So 2, let's say 1.5 divisions reduction, something like this. Yeah, that should be working.
So এখানে 3.5 boxes reduce করলাম না?
ওখানে তো অলরেডি 2 কমে গেছে।
হ্যাঁ, তো
The-
এখানে আরো বেশি কমাবো।
the deduction is going to become additive. ওখানে 2 কমছে, এখানে মনে করতেছি আরো 1.5 কমতেছে, তারপরটা আর2 কম কমাবো, তারপরটা আর2 কম কমাবো, এরকম। So you can plan ahead. For example, let's say if you don't want to, for example, I start with this with 2, so I am doing over 1.5. Maybe I'll do over here 1, then maybe I'll do 0.75, then I'll do 0.5, and then over here 0.25, something like that. How much you are reducing is something that you are not going to be judged upon, but did you do that did you do that change or not? That is something that will be that the examiners will check. But the cross points have to be exactly as before. That's very important. Sorry.
So কতটুকু reduce করে এর জন্য কি মার্কস আছে?
Nah. Nah. The exact amount does not matter, but the gradual decrease that representation matters. So there are 2 plus 1.5, 3.5 plus 1, 4.5. 1, 2, 3, 4, 4.5.
স্যার
Yes.
স্যার আপনি বলেছিলেন যে লাইক পুরো ফার্স্টে সবচেয়ে বেশি এনার্জি লস, এটা কেন?
Because the entire idea of fluid friction is that the faster your particle moves, the more strongly it collides with the friction medium. So you
সো স্যার একদম পুরো বিগিনিং এ কি সবচেয়ে স্পিড লাইক ফাস্টেস্ট, কারণ অ্যামপ্লিটিউড আমার বেশি।
yes. So you'll lose the biggest fraction of kinetic energy. So this is 4.5. 4.5 which last chilo 1. So I'll be increasing it by 0.7. Let's say I can draw this up to 5.
Sir, is there any specific rule you're following?
No. Acha, I'll write this down. একটু এঁকে নেই। And it will go further. So what I'm trying to show you, I mean, what is the rule that I'm trying to show you? First of all, the first rule of thumb is that all of these cross points should be exactly over here. These cross points should not shift left or right. If you do that, you'll be losing mark. That's number 1. Number 2, what I'm trying to achieve is that the first step, I have shown a reduction of 2. On the second step, I have tried to show a reduction of 2 plus 1.5. Over here, I have tried to show a reduction of 2 plus 1.5 plus 1. Here, I'm trying to show a reduction of 2 plus 1.5 plus 1, let's say, plus 0.8. And then maybe over here, I'll show a reduction of how much? Let's say 2 plus 1.5 plus 1 plus 0.8 plus 0.5 and then maybe 0.3. Then over here, this whole thing plus 0.3. So the point that I'm trying to create over here, the idea that I'm trying to create over here is that the amount of loss would be the biggest at the beginning. Slowly that loss amount would become smaller, but that those reduction are going to be additive. বুঝাচ্ছে?
হ্যাঁ স্যার।
তাহলে স্যার আপনি y axis এ রিডিউস করেন না কেন? মানে একদম লেফট সাইডে ফার্স্ট এটা নিচ থেকে স্টার্ট হয়।
এটা কারণ হচ্ছে যে this object was pretty much started with the same position. That's what your question says. I mean, your initial decision was exactly same. দেখো, the liquid B is now closed, so all the density there is a friction between the liquid and the tubes all the time. Having been displaced, the tube completes. Having been displayed, the tube completes 10 oscillations before coming to rest. So having been displayed, that they have only mentioned that. This usually means that it was displaced by the same amount. All they can specify করে নাই. So usually that's for oscillation cases, whenever we do overlapping curve, the initial displacement is always taken to be same. যদি এখানে specify করে নাই, but on অনেক কোশ্চেনে দেখবা, in many other questions you'll see that this is mentioned that the initial displacement was exactly same.
ওকে স্যার।
বুঝা গেছে কি everyone?
স্যার তার মানে ড্যাম্পিং এর সময় সবসময় এভাবে ডিক্রিজ করতে থাকবো।
That's the standard way. But we might as well look at the mark scheme to see how much precision did the examiner look for. Sorry. Continuous loss of energy or reduction in amplitude from the oscillating system caused by force. Acha na eta. Same period or small increase in period. Small increase in period কেন বলছে? What is this? I have no clue why this could be a thing, because in this case we do not have. Acha, examination দেখতে হবে. আচ্ছা, examination দেখি তারপর খাওয়া কই. Land disruption always less than that on figure 3.2. Ignore first T/4. Peak progressively smaller. This is what I mean. Progressively smaller. So by saying progressively smaller, they did not essentially mean that the reduction amount should be reduced over time as well. They only meant that the peak should be slowly become more and more smaller. So if you did draw a graph of, let's say, 1 division smaller, 2 divisions smaller, 3 divisions smaller, 4 divisions smaller, or if you went by a uniform decrease of 0.5, 0.5, 0.5, 0.5, 0.5 for all the drawing, according to this mark scheme, you would still get the mark. But what I just showed you is essentially what happens in a realistic case. Do I make sense?
Yes, sir.
So have a look at the mark scheme. There were some very good sketches that clearly showed all the features. The time interval for successive loops varied significantly, and there was no continuous reduction in amplitude. You see, there was no continuous reduction in amplitude. So continuous reduction of amplitude was an expected thing. Yeah, makes sense. Or to the question answer পাইছো?
Yes, sir.
Beautiful.
Sir,
Yes.
ড্যাম্পিং বলতে আমরা লস অফ এনার্জি ফ্রম দি অসিলেটিং সিস্টেম বুঝাই, কিন্তু মানে এনার্জি কি জিনিস, মানে অসিলেশন তো ধরনের কাইনেটিক এনার্জি তো হচ্ছে।
হ্যাঁ, কাইনেটিক এনার্জি হচ্ছে, বাট একটা অবজেক্টের স্টার্টিং এ যতটুকু কাইনেটিক এনার্জি বা পটেনশিয়াল এনার্জি ছিল, as the oscillation goes on, that total amount of energy becomes less. Part of the energy is dissipated in the surrounding.
আর স্যার আমরা যখন অ্যামপ্লিটিউড বুঝাই তাহলে কি ওই অ্যামপ্লিটিউড যে এনার্জি দিয়ে হয় ওটা কি কাইনেটিক এনার্জির কথা বলা হয়? যে আমরা যে বলি যে অ্যামপ্লিটিউড ডিপেন্ডস অন এনার্জি এন্ড স্টাফ, ওইটা
amplitude, I mean, there are different ways you can perceive this thing. সেটা হচ্ছে, one of the easiest way to perceive this thing is that other than considering a combination of both of the energies at the same time at a random point, to understand the total amount of energy, it's convenient if you consider one of the energies. For example, the way we did build up the equation for the kinetic energies, let me just pull that up. Here you can see the total energy expression was built up in this expression, half m omega square a square. That logic was explained to you. So if you consider this expression, if the total energy become less, that amplitude would also become less. So that's where this is the expression from where we derive that information.
ওকে স্যার।
বুঝা গেছে?
হ্যাঁ স্যার, মানে এখানে কাইনেটিক এনার্জি আর পটেনশিয়াল এনার্জির সাথে যে অ্যামপ্লিটিউডের রিলেশনটা মানে আছে, কারণে হচ্ছে গিয়ে ওটা বাড়লে ওটা মানে বাড়ে বা কমলে ওটা কম।
Yep.
ওকে স্যার।
Sure. Then number 7, 8, 9, 10.
Sir,
স্যার
Sir.
9C টা লাগবে 9C
বলো।
স্যার 9 এর B2 বুঝি নাই।
আচ্ছা, 9 দেখতেছি। A long strip of spring steel is clamped at one. আবিয়াস বলো। হ্যাঁ, সমস্যা নাই, বলো।
Sir, is in realistic situations there is no pattern in the decrease, right?
In realistic situation, there is a pattern in the decrease.
Like in the additive decrease, it doesn't. According to you, it doesn't really follow a pattern, does it? Or it does actually.
It does. It actually, yeah. It actually does. I'll show you. I'll give you your answer. I mean, let me answer Abiya's, and then I'll get into this question. Daro. Take a look at this. This is how underdamping looks like in a practical scenario. You can see that the amplitude reduction is sort of exponential. It's not linear. It's not finishing like this, bam. It's exponential. What does it mean? That the higher the value of y, bigger is the decrease of y as well. As the value of y is becoming smaller, delta y or loss of y is also becoming smaller and smaller and smaller, and it's apparently it is becoming asymptote. This is the actual case. That's why I went for that decremental loss.
So it's just a pattern where the loss just decreases as well.
Yes, it is a loss, but the amount of loss also decreases over time, because the slower your object moves, the less amount of energy is going to loss, because it's for primarily it's colliding with fewer amount of particles, and also it is colliding with them at a lower speed. So your loss of energy is not going to be that much.
Yes, sir. Thank you.
No problem. So question number 9 says a long strip of string metal is clamped at one end so that the strip is vertical. A mass of 65 grams is attached to the free end of the strip as shown in figure 2.1. Okay, good thing. The mass is pulled to one side and then released. The variation with time t of the horizontal displacement of the mass is shown in figure 2.2. So this is the displacement in centimeter. Here comes the graph. It goes on like that. The mass undergoes damped. The mass undergoes damped harmonic motion. Okay. Here this was 1.5. Here it is less than that. Okay, good. Explain what is meant by damping. The reason blah blah blah. Figure usually 2.2 determine the frequency. আচ্ছা এটা বের করা যাবে. Hence show that the initial energy stored in the still state before the mass is released is approximately 3.2 millijoule. Okay, initial energy to know for the initial energy. I mean, you can see that the spring metal strip was initially pulled to one side. I mean, the motion started with an initial displacement of 1.5 centimeter. So this you can assume as your initial amplitude. As the oscillation goes further, the amplitude slowly becomes less. So initially the amplitude or the maximum displacement in one direction was 1.5 centimeter. So what you can do over here is half m omega square a square. It's very important that you do the necessary unit conversions. Centimeter should be converted into meter, and that omega you get from radian per second over here. Over here you calculated what? Frequency. So from the frequency you have to obtain the omega, and then you can essentially calculate half m omega square a square. That should give you approximately 3.2 millijoule. Okay.
Sir.
হ্যাঁ বলো
Sir, 7B তে problem ছিল।
আচ্ছা যাচ্ছি একটু আগে ব্যাক করে যাচ্ছি। সি নাম্বার দেখো, after 8 complete oscillations of the mass, the amplitude of vibration is reduced from 1.5 centimeter to 1.1 centimeter. State and explain whether after a further 8 complete oscillations, the amplitude will be 0.7 centimeter. Okay, this might have been a problem earlier, but now you should be able to answer that, because I just discussed that thing in the earlier question. Would you have the same equal amount of decrease in amplitude as before for compared to the earlier and the later? Hey, no.
No.
This should be easily answerable right now, because I mean you are losing 0.4 centimeter of amplitude over 8 oscillations when your object was oscillating at a high speed. So you're not going to lose another 0.4 centimeter of amplitude in the next 8 oscillations. That's the whole point of that curve that I just showed you in this figure. So how much you lose for the first 8 oscillation, you're going to lose over the next 8 oscillation, you're going to lose less, and over the next 8 oscillation, you're going to lose even less and less and less. The whole point of having a approximately negative exponential looking curve. So ওই জিনিসটা এখানে ভাষার সাথে গুছাই লেখা রাখবে। আমরা ভাষাগুলো একটু দেখি so that we can make sure that we do not have any confusion from the mark scheme. This was number 9. See. Sorry. Amplitude reduces exponentially or does not decrease linearly, so it will not be 0.7 centimeter. Okay. Okay.
স্যার এটা কি 0.7 সেন্টিমিটারের চাইতে বেশি হবে না?
Yes.
আচ্ছা স্যার।
আর মুগ্ধ কোনটা বলছো?
Sir, 7B.
স্যার আমার আগের কয়েকটা কোশ্চেনে প্রবলেম ছিল আবার
আচ্ছা।
পিছনের দিকে
আচ্ছা 7B এর সেটআপটা আমি জানি. Beta was usually answered in A2 to show that the
Sir.
shadow on the screen is performs simple harmonic motion. আচ্ছা এটা প্রুফ করার সবচেয়ে সহজ বুদ্ধি হচ্ছে, I mean the simple way you can always prove this is that from the displacement equation you will find out the velocity, from the velocity equation you will find out the acceleration, and somehow you will come to the expression A proportional to minus x. That mathematical expression proves that it is SHM.
কিন্তু স্যার
বলো
মার্কস স্কিমে বলেছিল যে A2 এর ইকুয়েশনটা হচ্ছে একটা সলিউশন, মানে এটা বুঝি না।
ও ওটা মানে
আমার লিখছে যে ডিফারেন্সিয়েশন নাকি আমাদের সিলেবাস অ্যাকসেপ্ট করবে না অন্য আরেকটা জায়গায়।
কোথায় লিখছে?
স্যার লাস্টের দিকের একটা কোশ্চেনের ইআরএমএস এ।
আচ্ছা মার্ক করে রাখছো?
সিলেবাসে নাই।
ওটা কি মার্ক করা আছে?
না স্যার, বাট ওই কোশ্চেনটাতে প্রবলেম আছে, সো মনে হয় ওখানে যাব আমরা।
আচ্ছা ঠিক আছে, ওকে ফাইন, ঠিক আছে। If it shows up, I'll explain what that means. কত নম্বরে ছিলাম আমরা জানো?
7B করছি।
This is the solution of the equation a equals to minus omega square x. A equals to minus square omega is the defining equation of SHM. এই জিনিসটা মানে হচ্ছে এই ইকুয়েশনটা বুঝো। Acceleration means d square x by dt square, right?
Yes sir.
Equals to minus omega square x. So this is an equation, if you disregard the a symbol, compiled of x and t. So
Yes sir.
you can essentially solve this equation to find out the value of x in terms of t. Somehow if you can double integrate this equation with appropriate mechanism, you will end up with this equation. Now that double integration is not taught at your level. Rather than what we do, we double differentiation this to get this equation, which is easier.
Yes sir.
That's the whole point.
So this means this is a solution.
Yeah, that defining equation is basically the solution of the defining equation of the oscillation.
Sir, এইভাবে বলে হতো না যে we can like differentiate the original equation and get to this point.
I mean, the usual way that I go by is exactly what I just told you, that we get this equation and then we double differentiate this and eventually we can obtain that equation, hence proving that the motion that we're working does obey that relationship of a proportional to minus omega square x. But then again মিথিলা বলতেছিল যে ইয়া নাকি হবে না, কি হবে না?
স্যার মানে এক জায়গায় লেখা যে ডিফারেন্সিয়েশন ইজ বিয়ন্ড দ্য স্কোপ অফ দিস সিলেবাস, কিন্তু ওটা অ্যাকসেপ্ট হবে নাকি হবে না এগুলা মানে কিছু লেখা নেই, জাস্ট এটাই লেখা যে ওটা ম্যাথমেটিক্স এর সিলেবাসে নেই, মানে ফিজিক্স রিলেটেড ম্যাথস এর সিলেবাসে নেই, এটাই লেখা।
আচ্ছা ওটা জায়গা মতন দেখবো, don't worry, but I would go for this method that I would double differentiate this equation and then write up that equation stating that this is the defining equation for SHM. But since they did not do that, you might as well star mark this question to have a frequent revise. And remember that this first sentence that they have mentioned, that কি যেন first sentence ছিল?
A solution of the equation.
Yeah. X equals to S and omega t is the solution of the equation a equals to minus omega square x. You might as well learn to write this.
Okay, sir.
Okay.
Thank you, sir.
No problem. শুভ, তোমার কোথায় আগের কোশ্চেনে কোথায় প্রবলেম ছিল বলো?
স্যার আমার 1B তে প্রবলেম ছিল, 5 এ প্রবলেম ছিল।
1B আমরা অলরেডি আগে ডিসকাস করেছি। You need to see the earlier YouTube lectures to make sense out of it.
আচ্ছা স্যার, আমরা কি স্যার কোন পর্যন্ত শেষ করছিলাম তাহলে?
আমরা অনেকখানি গেছিলাম, মাঝখানে কিছু প্রবলেম আমি স্কিপ করে গেছিলাম because I wanted you to attend.
5 কি অ্যাটেন্ড করছিলাম?
হ্যাঁ, 5টা আমরা অল টুগেদার ইন ডিটেইলস এ করছি শেষ পর্যন্ত।
করছি। 8 also 8
দেখতেছি।
করা হয়নি।
8টাও করা হয়েছে। We did discuss why this motion would not be we did discuss that as well.
আচ্ছা, এগুলো
12A 3 তে সমস্যা।
আচ্ছা,
আগে কি 9 করবেন?
একটা করে যাই। নাম্বার 9টাতে ছিল, নাম্বার 9 তো করলাম।
স্যার 9A2, oh sorry স্যার 12 এর B2, sorry my bad.
আচ্ছা, আমি একটা করে যাচ্ছি, পরে মানে রেসপন্ড করো, ঠিক আছে? ট্রাই টু কিপ ইন লাইন। অনব শাহ, you have a question? Yes, please go ahead.
Sir, damping এ কি টাইম পিরিয়ড চেঞ্জ হয়?
ড্যাম্পিং এ টাইম পিরিয়ড চেঞ্জ হইতেও পারে, নাও হইতে পারে। It depends upon the damping mechanism that you have introduced in the system, whether that changes the mass of the oscillating body significantly or insignificantly. If the reason of damping is a mass addition, it adds a mass to your oscillating body, your time period will become larger. বুঝছো?
বুঝছি।
Number 10. Anyone? Eleven. No, চুলা কি দূরে বন্ধ? চুলা কি দূরে বন্ধ? আমার একটু লেবু চা খাইতে পারবা? লেবু চা আজে আইতেছে প্রচুর। Thank you, I appreciate this. আচ্ছা, 11 প্রবলেম নাই। 12
স্যার 12 এ আছে।
আচ্ছা, 12 এ কোনটাতে প্রবলেম?
8 তে স্যার।
2।
আচ্ছা, কোশ্চেনের প্রথম দেখে যাই। কোশ্চেন 12. A student sets out to investigate the oscillation of a mass suspended from the free end of a spring as illustrated in figure 3.1. The mass is pulled downwards and then released. The variation with time t of the displacement y of the mass is shown in figure 3.2. Okay, we are having undamped oscillation, as we can see. Time period can be found out. So okay, it's a good graph. Use the information in figure 3.2 to explain why the graph suggests that the oscillations are undamped to obtain the angular frequency of the oscillation. Possible? বলো।
অ্যাঙ্গুলার ফ্রিকোয়েন্সি বলতে কি বোঝাচ্ছে? ওটা তো অ্যাঙ্গুলার স্পিডই, মানে
angular speed and angular frequency pretty much mean the same thing, because I'll tell you why. Angle or theta, the unit of theta that we usually use, for example, theta can be expressed in degree or theta can be used in a radian. It does not have any measurable quantity equivalent. We use this symbol just to mean that it's an angle. If you wonder why, because the core equation by which we define an angle is S equals to R theta, right? S equals to R theta. Do you know this equation?
Yes,
arc length equals to radius into angle. So if we take subject theta out of this equation, we get S by R. So এদিকেও হচ্ছে length, numerator is length, denominator is length. So these two essentially cuts off. So theta essentially does not have any physical quantity based unit. We still use degrees or radian to mean that it is an angle.
Okay.
So if you have some theta to be, let's say, 25 rad per second, it might as well be said that it is 25 per second.
Oh,
But
আচ্ছা।
বুঝা গেছে?
Yes, sir.
Okay. And omega can also be called angular frequency as well. I mean, angular frequency and angular speed, angular velocity, they pretty much all have the same symbol, omega. So beyond this point,
Sir,
Bala.
sir, under damping or graph is close included.
কি জিনিস?
Under damping or graph দেখাবেন
কিসের গ্রাফ?
Under damping.
আমরা ড্যাম্পিং এর গ্রাফ দেখাবো?
না ওই যে দেখালেন ওটা মানে কি স্পেসিফিক কোনো গ্রাফ মানে আঁকতে হবে ওটা।
আমি তোমার কোশ্চেন বুঝতেছি না বাবা, আরেকবার বলো একটু কষ্ট করে।
আচ্ছা স্যার আন্ডার ড্যাম্পিং এর মানে কোন গ্রাফটা আমাদের মানে এক্সামে আঁকতে হবে যদি আসে?
এই যে এরকম গ্রাফ আন্ডার ড্যাম্পিং, অথবা যে the earlier graph that I did draw in the first question that I solved in today's class, that kind of graph, which essentially means gradual or progressive decrease of amplitude. That's it.
আচ্ছা
Okay,
স্যার
okay, hold up. Question টা আমি সলভ করিনি, তারপর তোমাদের কোশ্চেন আমার নিচ্ছি। To determine the maximum speed of the oscillating mass, maximum speed breaker is simple. V equals to plus minus omega A, or you can simply calculate V equals to omega A. Determine the resonant frequency F naught of the mass spring system. That will be omega equals to 2 pi F. 2 pi F the frequency বের করবা। The student finds that if short impulsive forces at frequency half F naught are impressed on the mass spring system, a large amplitude of oscillation is obtained. Explain this observation. I'll explain this observation and then I'll take questions. Listen up very closely and try to understand. The entire idea of having a frequency, having a driving frequency that is exactly equal to the natural frequency of an object can mean something like this. Let me put it this way. Let's say the natural frequency of an object is 12 hertz. The natural frequency of an object is 12 hertz. Now, if you apply an external force at exactly 12 hertz, what you're going to do, you're going to push the object forward when the object is trying to go forward on its own, and you're going to pull the object backwards when the object is trying to come backwards on its own. So you will be adding energy to this system in both of its movement, forward, backward, forward, backward. So you'll be adding up energies and that will build up to give you a large amplitude. Essentially, we call this resonance. That is the case when the external frequency, or we call the driving frequency, is equal to the natural frequency of the oscillating system. What if we apply a frequency of force of 6 hertz? Then what's going to happen? Now, having a force applied at 6 hertz mean you are going to provide force at every other oscillation, which means you are going to apply the force in the first oscillation, then you are not going to apply the force on the body in the second oscillation, then you're going to apply the force on the third oscillation. You're going to skip one, because your external body, your driving body, is moving at half the frequency compared to your oscillating object. But because it is exactly half, you will be adding energy in every odd number of oscillations, one after another. So it means that you'd still be able to add up energy into the system. This adding up of energy would not be as rapid as 12 hertz driving frequency, but since you are not essentially opposing the motion anyhow, you're still supporting the motion, you're always applying force in the same direction of the motion, but you are doing this less often. So you can still make it happen for the object to slowly build up its amplitude. That same thing is also applicable if you give another full fraction of 12 hertz. For example, let's say 4 hertz. That is 1/3 of the natural frequency. If you apply your driving frequency at 1/3 of the natural frequency, 4 hertz, then you're going to miss 2 oscillations. So you're going to apply, let's say you apply the force in the first oscillation, you're going to miss 2 and 3. Then again, you're going to once again apply force in the 4th oscillation as the object is going forward. Then you're going to miss 5 and 6. Then you're going to apply the force on the object in the same direction on the 7th oscillation. So you are going to add up energy in the oscillating system, but the amount of energy or the rate of energy supplied would be less. So you can build up a resonance, but it is going to take even more time. Bottom line, if you apply full fraction of the natural frequency on a system, you can make resonance happen. The smaller the fraction, the longer it is going to take. However, it is not possible for a non-full fraction. For example, if you go, let's say the natural frequency of a system is 12 hertz, and let's say you are applying a force of 8 hertz, so which is not a full fraction, it's something smaller. Then what is going to happen? The problem that we're going to come by is that at that frequency, you are not going to be in perfect sync with the object's natural motion. So let's say the object completes one full oscillation within t amount of time, but your time period of your object is less, so you are going to take longer than t amount of time, which means by the time the oscillating body has moved back to its original position, your applied force could not reach to the original position. It takes more time to come to its original position, which means when the oscillating body is going to start to reverse its direction, your source is still pushing it backwards. So within its motion back and forth for the oscillating body, you are going to add up energy for certain portion of the motion. Then again, for certain part of the motion, you are going to oppose that motion. So you're going to you are going to work positively and negatively on the system alternately. So you cannot build up a large amount of energy. But if it is a full fraction or an integer fraction of the original natural frequency, you can build up that energy amount. And also vice versa, this is only possible for full fractions. This is not going to ever happen for full multiples or any other multiple, for example, per se. For example, if the natural frequency of an oscillating body is 12 hertz and you apply a force driving frequency at 24 hertz, then what's going to happen that when the object is going forward, you are going to apply on the object a forward and backward force both within this part. So for half the motion, for exactly half the motion, you'll be adding up energy. For half the motion, you'll be taking out energy. So if that is the case, then you will be continuously working positively and negatively on your oscillating body. So you cannot build up that energy. But for full fraction, you can do that. Okay, I'll now take questions one by one. So Fardin Amin, bolo.
Sir, আপনি যে বলেন আপনার আপনার 12 hertz হচ্ছে আমার ন্যাচারাল ফ্রিকোয়েন্সি, ওখান থেকে যদি আমি 6 hertz ফ্রিকোয়েন্সিটা দিই, ড্রাইভিং ফ্রিকোয়েন্সিটা, সো স্যার আপনার রেজাল্টেন্ট অ্যামপ্লিটিউড 0 হয়ে যাবে না স্যার?
না, রেজাল্টেন্ট অ্যামপ্লিটিউড 0 হবে না। তার কারণ হচ্ছে যে try to visualize 6012 hertz.
স্যার একটু একে বুঝালে বেটার হয়।
এটা আমি আসলে একে বুঝাইলে পারবো না, আমি আর এটা কোনো ভাবে অ্যানিমেশন দেখাতে হবে, দাঁড়াও।
স্যার ন্যাচারাল ফ্রিকোয়েন্সির থেকে কম ফ্রিকোয়েন্সি দিলেও কি একই জিনিস ঘটবে, মানে অ্যামপ্লিটিউড বাড়বে?
র্যান্ডম কম দিলে হবে না, ফুল ফ্র্যাকশন হইতে হবে।
ও আচ্ছা।
মামুন,
স্যার আপনি কি আসলে বুঝাতে যাচ্ছেন যে পুরো রেজোন্যান্ট ফ্রিকোয়েন্সি এক্সাক্ট যেটা ওইটাই আসতে হবে আমাদের, ওটার মাল্টিপল বা কিছু হচ্ছে অ্যাপ্লিকেবল হবে না, তাই তো?
এক্সাক্ট ন্যাচারাল ফ্রিকোয়েন্সিতে অ্যাপ্লাই করলে তোমার সবচেয়ে ভালো হবে, বাট তুমি যদি এক্সাক্ট ন্যাচারাল ফ্রিকোয়েন্সি ফুল ইন্টিজার ফ্র্যাকশনে অ্যাপ্লাই করো, তাও তুমি রেজোনেন্স বিল্ড আপ করতে পারবা,
লাইক 1/4 অর এইভাবে বাড়ানো বা হাফ করে বাড়ানো,
হাফ, 1/3, 1/4.
So then why won't 2/3 or 3/4 fractions like those work?
I'll show you that. Animation. Can I manipulate this thing?
So you can search for something called Oscillation Simulator or something similar like that.
Beautiful. I forgot the word simulator. But there is only one object here. All right. So what? Okay, this is gonna work. This is actually gonna work. This is nice. I'll explain what is happening. So at 0 hertz, nothing is moving. This is actually cold. This is a good thing. So we have different mass systems. So different mass systems are gonna have different resonant frequency. So you can see that in this resonant frequency 0.8 hertz, the right object is moving with pretty large amplitude for whatever reasons that is. Now the middle one is moving pretty loud. Which one is having the biggest amplitude? The left one, right?
লেফট করো না, একদম লেফট নষ্ট। 1.9 এটা কি হইতেছে আসলে?
তো আপনি ফ্রিকোয়েন্সি বাড়াচ্ছেন আস্তে ধীরে?
That's what I'm trying to do.
স্যার 1.9 এ যে দুইটা লুপ হয়ে মানে দুইটা ওয়েভ হয়ে যাচ্ছে। Yeah, দুইটা ওয়েভ হয়ে যাচ্ছে রাইট মোস্টার।
Yeah, because you have the same medium and you have.
Sir, why does the left one have maximum oscillation, the left one?
This is amazing.
It is pretty cool.
Acha. This is just a basic idea of stationary wave that is happening through the medium. We have nodes and antinodes, but let's not go for multiple loops. Let's limit our observation for a single loop. Okay, this is a slinky. That's why we're having this thing. If this was not a slinky kind of object, for example, if this was a single string and a single mass loaded, this observation might have been easier. But since they have not given us this opportunity, so we might as well use this. So I'm not gonna build up 2 loops. I'm gonna work with a single loop. So let's have a look. At 0 hertz, everything is stationary. 0.1 hertz, almost nothing. 0.2 hertz, we have some movement. Still almost nothing. Now we are having some movement going on. 0.5 hertz, not much. 0.7. Is it possible that I can actually place a so we do not have the, no, we do not have the, Okay. Whenever the frequency of the system is set at 0.8 hertz, you can see that this object is moving pretty loud, right? So if I go for 1 hertz, then the maximum amplitude is belonging to this one, right? Have a look. Is that the case? What?
স্যার আপনি পেন্ডুলাম একটা সার্চ দেন।
So web browser simulations may not be the best, but they get the job done.
Okay. How do I start this?
স্যার এইটা কোথা থেকে পেলেন?
Net থেকে পেলাম। Okay, so see what just happened? Where is this? Where is 0? Okay, so this is 0, no oscillation. How can I increase this gradually? Or I have to use the mouse? Sami, কি অবস্থা?
I guess আপনি টাইপ করতে পারবেন।
I think that works, right?
think this is the resonant frequency.
Wow. What?
So you should really record that and play it on loop.
I should superbly, I mean, I should definitely bookmark this in the first place. Done.
This is amazing.
This is cool.
Sort of accept my thanks in my inbox.
Yeah,
Thank you.
definitely. Super thanks. The word simulator didn't even pop in my head. Okay. I'm not sure if I'm wasting too much time to explain this over here, but I might as well give it a try. I'm trying to find out the resonant frequency for this thing. So have a look. Where do we have that resonance frequency?
So the resonance is probably 1.345 hertz.
It says on the right side, like
Now it's 2.2.
now it's 2.251.
Now it's 5 hertz. Yeah.
Why are you seeing this?
Sir, in the resonator.
Resonator box, like in the bottom.
Where?
In the blue box, sir.
Here.
Yes, at the bottom of the blue box.
Oh, yes. Thank you. I did not see this. Okay, I want to make this a convenient number. Let's say 12. So what do I have to do? Make the object pretty light or the spin constant pretty large. Okay, spin constant really large. And if we go, okay, 12. I'm trying to get it 12 because I want to discuss with 12. So let's say I make this 12.
It won't go beyond 6.
Oh.
So you could just type it in.
4 দিয়ে try করি।
Okay.
স্যার নিজে আগে স্পিডটা অ্যাডজাস্ট করা যাবে
কোনটা এখানে
হ্যাঁ মনে হয়
Oh my God, this thing is going haywire. Okay. Yeah, বাড়তেছে একটু কমতেছে না? It's not exactly 4, that's why.
Oh dear.
I cannot make it exactly 4. Why?
স্যার একটু মানে যে টাইপ করে চেঞ্জ করতে পারেন স্প্রিং কনস্ট্যান্টটা
কত লিখবো?
60.5 61 maybe I don't know.
Oh, awesome.
And then
তোমরা তো অস্থির।
thank you sir.
এটা একটু বাড়াইতে হবে নাহলে অবস্থা বেশি খারাপ হয়ে যাচ্ছে। Okay, I'll live with that. Okay, so what I want you to see over here, that when the frequency of the system is exactly 4 hertz, whenever our oscillating object is applying our force frequency of 4 hertz, we're having the maximum oscillation. Okay, this means what? Let me just pause it. This means I'll slow down the theme speed. I'll slow it down even more. Have a look. Okay, I'll do step so that I can explain. this is the position where the object has come to its lowest point. Do you see it? The object is at its lowest point. Now, you'll see that as the object is starting to go upwards, this base is also going to start to push it upwards. So it will support the motion of the object. Have a look. Do you see it? Object going up, base is also going up. Take a look. Like that, like that. As the object comes down, base is also coming down. As the object is going up, base is also going up, which means the base or the force or the source or the force oscillation that is essentially providing energy to this oscillating body in both of its motion, upwards and downwards. It is pushing it upwards and also pulling it backwards. Make sense? Pulavan,
Yes, sir.
respond.
So
Okay.
this is the resonance frequency, right?
Yes,
This is the resonant frequency, exact resonant frequency. So we have set the frequency at 4.00 hertz. The resonant frequency is 4.001 hertz. So it's almost equal. So now, if we change this to a full fraction, let's say if we change this to 2 hertz, we're going to try and see what's going to happen. So let's say now we have made this into 2 hertz. So what is happening?
অ্যামপ্লিটিউড কমে গেছে or
It looks out of sync, sir.
yeah, like অ্যামপ্লিটিউডটা কমে গেছে.
This spring doesn't change in shape, does it?
Wow. Oh my God.
That was devilish laughter. My God.
Sir, are you okay?
I'm okay. I'm just
Yeah, your laughter must be
I'm
recorded.
speechless.
Your laughter must be recorded.
It did get recorded, don't worry. I think the spring constant is too strong for this to give us any movement. So how about we all together change our priorities and let's go for some softer spring. That's it.
What is this?
Even that is
Sir, chill.
This is because I turn on the gravity. If I turn off the gravity, then it becomes.
Oh, acha.
It just goes out of the damn window.
It is crazy. I mean, dang.
This is a pretty good simulation, even though
Yes.
it's simple.
I'm surprised that this spring is snap off yet.
I'm not even kidding.
Arafat, what is this coded on?
I have no idea, man.
Oh, come on.
Whoever did this did consider a lot of variables. I mean, hands down. At least that's what it looks like. Okay.
These Colorado simulation things are pretty good sometimes. I think they even had a momentum simulator. I used it.
Okay. So I have increased the mass a little bit and the damping constant was reduced to a very minimum. So now I have once again made the frequency 4 hertz. So if we apply the exactly 4 hertz, then we have the highest of the amplitude. So if I slow down the stimulation, so that's the amount of amplitude that we are having, like super amazing. I might as well increase this a little bit. Let's say 1, if I give it 1 or a bit more, or I could actually reduce the amplitude rather than dealing with this one. Okay, now we have regular amplitude. So this is the largest amplitude that we have. So now if we halve the frequency, have a look what is happening. What we get is the exact same thing as earlier.
স্যার ড্যাম্পিং কনস্ট্যান্ট যত কম হবে তত তো মানে অ্যামপ্লিটিউডটা বেশি আসবে আর না ইয়া অ্যামপ্লিটিউড বেশি আসবে না তত স্যার
I cannot make sense out of it. It's supposed to work.
Why does the spring freeze, sir?
Maybe because both of them are moving in phase with the same amplitude, that's why. Maybe.
Yeah, but I can't imagine this happening in real life.
স্যার ওয়ান এখন মুভ করছে
না
মাঝে মাঝে করে আবার মাঝে মাঝে ফ্রিজ হয়
Acha, I have to figure this out, how to work with the simulation. I'm wasting a lot of time, but I'll definitely be used to utilize some time on this one, beyond this one. What I actually wanted to mean in layman's term, if I don't use the simulation, is that whenever আমি এখানে এগিয়ে দেখাই মনে করো এটা হচ্ছে আমার অসিলেটিং বডি মনে করো এটা হচ্ছে একটা অসিলেটিং বডি না এরকম না I'll take one picture from the figure না আমি আঁকি সমস্যা নেই so let's say this is a table and this is a wooden piece that is clamped on the table with appropriate setup and everything and so we have some clamping mechanism over here, let's say clamping mechanism, and then we are going to oscillate this end by applying some force, or we are going to attach a mechanical vibrator at this location. So we have a vibration mechanism over here which is going to do its own vibration, and that is connected with some wire. So this vibration is going to cause this entire thing to vibrate. So with this one's mass and the amount of the mass of the ruler for the open part, it will have a natural frequency. The idea that I try to pass through you is that if the natural frequency of this ruler is, let's say, 12 hertz, then if you apply 12 hertz, you're going to get a pretty large amplitude, which makes sense. What this would mean, when this ruler is naturally trying to go down, this oscillator will also push it down. When this ruler is trying to go up, this oscillator will also push it up. So it is going to start. So this oscillating mechanism will pull up and down the ruler in the same way the ruler wants to move, which is the best case scenario. If it is not 12 hertz, if it is 6 hertz, then what's going to happen? This ruler, as this ruler starts to move downwards, I mean, this is half the frequency, means how can I show you this? ওখানে পালস ফোর্সের কথা বলছে না না কন্টিনিউয়াস ফোর্সের কথা বলছে ইম্পালসিভ ফোর্স এক্স্যাক্টলি আমি এটা কথা ভুলে গেছিলাম ইয়েস মনে পড়ছে I'll show you why that system was not working for my explanation. It will become very clear right now. For a spring system, this is not going to work. It is only going to work for short impulsive forces. Now, what do I mean by this? I'll make this clear right now. মনে করো এখানে আমাদের এই সেটআপের পিছনে একটা স্ট্যান্ড আছে, this is the groundের উপরে একটা স্ট্যান্ড আছে, there is a stand on the ground and we have a stand going up over here. This is the stand which is expected to be behind the ruler, so disregard these parts, so it is behind the ruler. And actually never mind. So, and let's say using some clamping mechanism, we have provided over here an oscillating mechanism which has a peg that is, let's say, labeled red, that is touching the ruler over here. This thing is stationary. This object is perfectly held stationary, where this peg is going to go up and down like a sewing machine. Can you visualize this? This red thing is a moving up and down peg that can go up and down inside this vibrator, which is connected to some electrical circuit or that operates this going up and down. So this peg is going to hit this ruler at this position continuously. Do you make my point? Get my point? Hello?
This is what you consider as short and impulsive, sir?
Yes. So what I mean is that this thing is not going to move very slowly. And I mean, the velocity of this object is going to be pretty fast. So it's going to flick and go back and wait for the next flick. So the pulses that this thing is going to make, they're not going to be like this. The forces that this thing is going to be making are going to be something like this. No force, no force, no force, bam. No force, no force, no force, bam. No force, no force, no force, no force, bam. So it's going to really come down sharp at a pretty high speed, give it a bump, and immediately go back. So it's not going to be continuously applying force up and down, being in contact, not like that. It's going to hit like a hammer.
Between these spikes are very small, right, sir?
The spikes, the value of these spikes might be large, but the duration of these spikes are very small. That's very important.
But the time between consecutive spikes is really small, right?
No, the time between consecutive spike is large compared to the duration of the spike. What I mean is that for the longer period of the time of the whole motion, this peg or this source, this force applying thing would not be in contact with the ruler. For the longer duration of the part, this will be out of contact. For example, this much part. And for a small duration of the whole motion, it will apply the force. That's why we are saying short impulsive forces. Does this idea make sense? Short impulsive forces. এই কনসেপ্টটাকে ভালো করে বুঝো। Poloman, please respond.
Short impulsive forces.
Yes.
Could you repeat one more time, sir?
It means that the vibrating mechanism that you are introducing in this setup will not apply a continuous force onto our oscillating body like a sine curve. It is going to apply forces like a poke. So this thing, I mean, if I just try to give it a better visualization. For example, this thing is going to let me draw that rectangle, another one. So this thing is going to so this thing is going to come out of this box and hit the ruler and immediately go up and wait, and then again come down, hit the ruler and go up and wait, like that. So the collision time with the ruler is going to be pretty small, this much, and the waiting time is going to be pretty large. So it's not going to be in contact with the ruler and make the movement up and down and up and down. It's going to be like a punches or pokes onto the ruler body. So as long as the force is going to work, that's going to be pretty sharp, but the application duration of the force is going to be significantly small compared to compared to one time period, for example.
It makes sense, sir.
Short impulsive forces. Does that idea pass across? Hello?
But that means the direction টা always same থাকবে force right? মানে just
Yes.
একটা pulse-এর মতন দিতে থাকবে।
Yes, this thing will only apply force downwards. This thing is not going to be able to push force upwards. This peg will only be able to push the meter rule downwards, not upwards. So what I mean, now try to understand. When the frequency of this peg is, let's say, 12 hertz, then it is going to hit this ruler every second 12 times. And this meter rule is going to go up downwards every second how many times? Naturally?
12 hertz.
12 times. So it has a natural frequency of 12 hertz, which means each second, it will be going upward direction 12 times and it will be going downward direction 12 times as well. So if this peg gives short impulsive forces onto this ruler at 12 hertz, eventually their motions are going to sync up in a way that at every downward motion of this ruler, this peg is going to do the hit. And because this is going to be last for such a short time, the energy transfer is going to be pretty rapid, and then the peg is going to go up and will not obstruct the ruler's upward motion. Short, the significance of short. This peg, which is hitting the ruler's body, will not obstruct the upward motion. It will only add force in the downward motion.
স্যার তার মানে অ্যাকচুয়ালি টাইম ডিউরেশন যখন ফোর্স অ্যাপ্লাইড হচ্ছে সেটা হচ্ছে শর্ট আর কি।
Yes, that's what I meant. That is exactly what I want you to consider. So having a 12 hertz of short impulsive forces will give us resonance because the energy in the motion is continuously being added up. However, if we apply, if we say set this device at 6 hertz, then what's going to happen? If we apply this object at 6 hertz, it means now this peg will not hit this ruler 12 times every second. It will hit the ruler how many times? 6 times every second. But the ruler is naturally going to vibrate at what frequency? 12 hertz. Which means this peg will hit this ruler for every other going down motion. So let's say this ruler is going down. If this peg hits this ruler at the first downward going motion, then it is going to skip the second one. Second টাতে কোনো রকম ফোর্স দিবে না। তারপর সে আবার থার্ড টাতে সে আবার একটা ডাউনওয়ার্ড মোশন দিবে। Then আবার ফোর্থ টাতে সে কোনো মোশন দিবে না। But in any of the cases, this peg is going to apply that force for a short time and then leave out of the path of the ruler. So this peg will not exist there to obstruct the motion. Short impulsive forces.
মানে স্যার এবার টাইম পিরিয়ডটা অনেক বেশি হবে নাকি?
টাইম পিরিয়ডটা আমাদের ফোর্স অফ অ্যাপ্লিকেশনের থেকে অনেক বেশি হবে।
আচ্ছা বুঝছি স্যার।
ঠিক আছে? So because this short impulsive forces are short impulsive forces, so they will be providing energy to our oscillating ruler system at a much less amount with respect to time. আগে আমরা earlier we are applying this force every second 12 times. Now we are providing the force, or we are adding energy in every second only 6 times. But we are not obstructing the motion. We are not applying the peg downwards when the ruler is trying to come upwards, because that would be deceleration. In every single push, we are trying to push the person. It's sort of something like that. I mean, a very common practical example. This didn't pop in my head first. The way we usually swing a person in a swing. How do we swing it? You stand back, they lean, they come backwards, and they pretty much reach up to the highest position. Then we give a push, right? Think about it. If you are making someone to ride a swing, what do you do to make the swing ride become more exhilarating? We give the swing person push as the person goes down, so they get a bigger amount of energy. So you do some work on them and they get a larger amplitude. Then you do not obstruct in their path, you do not slow them down, you get far away. The person goes in the forward direction and then they fall down and eventually come up to the maximum position in the behind. Then as they start to go downwards, only then do you push them again. So that is a very good example of short impulsive forces, which means that you are always applying force in the same frequency of the swing person, only that you are applying the force in only a single direction. Short impulsive forces. You're not applying the force on the object for the entirety of the motion. Can you visualize this thing?
স্যার তাহলে 6 হার্টজ এ দিলে কি হবে স্যার? আমরা যখন 12 থেকে
In the case of 6 hertz, this person is going to apply force by skipping every other swing. Let's say if he pushes on the first going down motion, he is not going to push on the second down going motion. He's going to just be there. But he's going to add the force. He's going to push again in the third down going motion. But he's still going to add force in the same direction. So he's still going to add energy to the system. Check this out.
Resonance is happening, just slower.
Resonance will happen, but it will happen a bit after a bit longer.
Okay.
Do I make sense?
Yes, sir.
লাইক স্যার একটা পয়েন্টে এসে হচ্ছে যখন মানে সিঙ্ক করবে তখন রেজোন্যান্সটা হবে বেসিক্যালি, তাই না?
এখানে প্র্যাকটিক্যালি আমরা সিঙ্ক করার কথা বলতেছি না, because the two frequencies are not exactly equal. What I am trying to give you is that the energy is being added to the system without any deceleration. The impulsive forces are not trying to decelerate the object. The impulsive forces are always pushing the object in the same direction.
মানে সবসময় যখন আপ থেকে ডাউনে যাচ্ছে তখনই হচ্ছে ফোর্সটা দিতেছে।
Exactly. That's how swing rides are made.
Yeah.
Okay, so that will eventually slowly start to make the energy of the swing go higher, and that's essentially what we mean resonance. So build up of the energy. So you can achieve this by applying a frequency of exactly half, in which case you'll miss, you'll do push, not push, push, not push, push, not push, like that. So you'll skip one oscillation. If you do this at 1/3 of the frequency, then you'll miss 2 of the oscillations. So you'll push, let's say 1, you'll miss 2 and 3, then you'll push in the 4th. Because your frequency is 1/3 of the object's frequency, so you will be applying force onto the oscillating body, short impulsive force, for every 3rd oscillation. In that case also,
বাট স্যার 6 হার্টজে তো এটা হচ্ছে না, 6 হার্টজে একটা মনে স্কিপ করছে মাঝখানে।
আমি তো ওইটাই বললাম যে 6 হার্টজ এর জন্য আমরা একটা করে স্কিপ করব, 4 হার্টজ এর জন্য দুটো করে স্কিপ করব, 3 হার্টজ এর জন্য 4টা করে স্কিপ করব, 2 হার্টজ এর জন্য 5টা করে স্কিপ করব। Make sense?
So like resultant force add up হয়ে হবে তো স্যার, রাইট?
Resultant work done add up হবে।
হ্যাঁ।
And that work done, resultant added up work done will eventually build up to give us a large amount of energy, which will be expressed as resonance. But that is not going to happen if you go for multiples of this force. Because if you go for a multiple of force, for example, let's say if this force was 24 hertz, this would mean that as the person goes forward, we're going to push them once, and as the person is trying to come backwards, we're going to also push them once forward. So we are going to add energy in the forward direction, but as the person comes backwards, we're going to reduce the energy by doing deceleration. Because in once, so a bigger frequency would not make this happen, but a complete fraction would this happen. If you wonder why do you need a complete fraction, if we do not have a complete fraction, for example, other than having 6 hertz, if we apply a force of, let's say, 8 hertz, if we apply the force at 8 hertz of impulsive frequency, sorry, short impulse of impulse frequencies, impulsive forces, then the problem that will happen that up within this 8 hertz, I mean 8 times of the force application, some of them will sync up in the forward direction, some of them will not. Some of them will sync up with the forward direction, but some of them will not. If you wonder how does that happen, I can show you this with a graph, which should make sense to you. এখানে সাইন কার্ভ জানা কেমনে বানায়?
Sin x লেখেন।
Y is equal to sin x, sir. And there's the virtual keyboard at the bottom.
Okay, I want this horizontal axis to show up in degree. How do I do that? তো মহা প্যারা দেখা যায়।
So you might want to alter the scale of the horizontal axis.
হ্যাঁ,
The scale of the horizontal axis.
শুধু horizontal scale কি শুধু horizontal axis কি স্কেল করা যায়?
Like x-axis, sir.
এটা কি করা যায়?
হ্যাঁ স্যার, ওই যে x axis দেখা যাচ্ছে ওইখানে।
Step.
Yes, or no, what you asked is correct. এটা
না স্যার, the y-axis.
ওই যে সেটিংসটাতে ওই যে x axis লেখা আছে, y axis লেখা। হ্যাঁ
Yes sir, yes.
হ্যাঁ
90 then sir. 90 then. 90.
ওখানে স্যার 9360 লেখা। না না, ওটা স্টেপ দিয়েছেন আপনি রেঞ্জটা দেন।
Oh. And প্রবলেম তো হচ্ছে যে আচ্ছা এটা 10 বানাবো কেমন এখানে 10 লিখলে হয়ে যাবে তাই না beautiful I love you kids okay fine we have this graph let's say this is the graph of this thing okay what is the time period over here what is the time period the cycle duration is 360 degree ঠিক আছে now let's say if we have a frequency that is half if you have a frequency that is half so let's copy this equation because I'm just going to make changes to this equation so let's say another one if you have a frequency that is half in that case this should become x by 2 or 2x omega t
2x, sir. If you want to have, wait, no. If you want to have frequency, then
no,
it's
x by 2.
X by 2. Half frequency x by 2. Just divide, sir. Divide. The divide button.
So ব্র্যাকেটের ভিতরে মানে x টাকে ব্র্যাকেটের ভিতরে লিখে x ডিভাইড বাই 2 লিখতে হবে।
Yes.
Okay. ঠিক আছে এখন মনে করো আমি এই পিক দুটাকে ম্যাচ করব কেমনে
প্লাস 19 না স্যার বাইরে প্লাস 19 না মাইনাস 19 না স্যার 45 প্লাস 45 হবে
I love you so this is what I'm meaning say this whenever we doing the half the frequency let's say this is the oscillation graph for the swing or the ruler and this is your applied force direction but you are not applying force in this gradual way you are only applying force let's say over here a short impulsive force so I want you to visualize this graph like bam 0 force bam অনেক বড় একটা force then wait bam বুঝাচ্ছে কি বলছি assume that this application of the force is happening only at the previous position so you're always syncing up and then you can also have this if you have it let's say x by 3 and blah 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 so if I give it x by 3 and then you if I add it by 30 না কত হবে এটা
45 হবে স্যার
45 হবে 45 হলে তো ম্যাচ করতেছ না
Start to see the difference of angles at the peak when there is no.
This is 135. This is 90. So this is 45.
Sorry, gotta erase.
স্যার এইটা কিভাবে সেট করতেছেন আপনি ট্রিগোনোমেট্রিক ইকুয়েশনটা like
I'm assuming that the red graph is the graph of the natural frequency moving object. So that's how our oscillator object wants to move, and the blue graph is the type of force that we are trying to apply.
Sorry,
so x by 3 is like
plus
sir,
270. Plus 270, sir.
না স্যার প্লাস 180
plus 180 হবে স্যার
Does this work? Can I revert this?
স্যার পুরোটা ইনভার্স করে দেন তাহলে
স্যার আরো 180 ডিগ্রি শিফট করলে প্রবাবলি হয়ে যেত
আচ্ছা সমস্যা নাই এটা তো বুঝে পারবো so this is the case where you are skipping two of these oscillations let's say you're going to apply the force over here you're going to miss two of them and then you're going to apply the force on the third one so that's the case for the fraction but if you don't have a fraction let's say your natural frequency was 12 hertz then if you apply a external frequency of 8 hertz only in that case things are going to not become synced for example for 8 hertz we would require variable for example এখানে আমাদের সাইকেল লেন্থ ছিল কতটুকু 360 ডিগ্রি না
Yes, sir.
শর্ট ইম্পালসিভ ফোর্স গুলো কি আপনি ব্লু লাইন দিয়ে বুঝাচ্ছেন
সরি
ব্লু লাইন দিয়ে কি বুঝাচ্ছেন না আপনি
হ্যাঁ
শর্ট ইম্পালসিভ ফোর্স গুলো
No.
হ্যাঁ
On a short impulsive forces, sir.
Short impulsive forces are assumed to be applied only when the blue lines are peaking, not for the entire part as
অনেক
the graph
লং
shows.
পিরিয়ড অফ টাইমে না
Yes, because your frequency has become half or 1/3 or 1/4.
Okay. I
That's why
understand.
your frequency is time period is large.
I understand, sir.
শুভ বুঝছো?
হ্যাঁ স্যার বুঝছি
আচ্ছা, এখন এটাকে যদি আমি x/3 না দিয়ে ফুল ফ্র্যাকশন না দিয়ে মনে করো x/2.5 দিয়ে দিলাম, তখন যে জিনিসটা হবে, আমরা যদি ইভেন একটা সার্টেন পয়েন্টেও সিঙ্ক পাইতে পারি, মনে করো হচ্ছে আমি কোন একটা সার্টেন পয়েন্টে সিঙ্ক হবে সেই পয়েন্টটা খুঁজে বাই করি, তাহলে আমার কষ্ট কম হবে। কোথাও সিঙ্ক হচ্ছে না কেন? আচ্ছা, হচ্ছে না। এখানে কত দিলে সিঙ্ক হয় বলো, হেল্প করো, তোমরা তো সব ম্যাথমেটিক্যাল জিনিয়াস। 180 এর সাথে 45 অ্যাড করলে কত হয়? 225 না?
স্যার কিভাবে অ্যাডজাস্ট করার চেষ্টা করতেছেন, মানে হোয়াট ডু ইউ
ট্রায়াল
ওয়ান্ট
এন্ড এরর।
হোয়াট ডু ইউ ওয়ান্ট অন দ্য গ্রাফ
I want these peaks to match up.
So you can just see how far they are
ইয়া স্যার কয়
They
ডিগ্রি
are 90
গ্যাপে
degree
আছে
apart.
and translate accordingly. Sir, they're about
Plus 90 হবে
প্লাস মাইনাস 90 কিছু একটা হবে না, এখানে তো ডিফারেন্সটা
Plus 36. I'm not sure. Okay, normal.
স্যার একটু কম হবে মনে হয়
চুপ থাকো। If we place x equals to দাঁড়াও, x equals to দাঁড়াও, আমি সহজ হিসাব করতেছি। x divided by 25 plus x divided by 2.5 plus c equals to 90, এটা বাই করে দাও তো কত হয়? x divided by 25 plus c, x টা হচ্ছে 90 divided by 25 plus c, 90 কে 2.5 দিয়ে ডিভাইড করে দাও কত হয়?
36 sir
90 divided by 2.5 কত আসে?
36 আসে
আচ্ছা, 90 minus that
54
there you go, bam. আমি মাথা খাটাখাটা করতে যাচ্ছিলাম না, যেন ট্যালেন্টের মারতেছিলাম, বাট সময় নষ্ট হচ্ছিল খালি। লাইফ। যেটা বলতেছিলাম যে if we apply a frequency that is not a full fraction, let's say I have over here conveniently used a fraction, so you can see that let's say we are applying the first push over here at the perfect time, but then the object is trying to oscillate in the rate frequency, but you are going to apply the next push forward when the object is trying to come backwards. See, there is a huge mess up. So the amount of forward work you are going to do in this push, you're going to obliterate that amount of work done in this push. So you're going to essentially accelerate the system over here, and you're going to essentially decelerate the system over here. So you cannot build up the energy. So resonance cannot happen.
Sir, can you add the waves together so you can see a resultant wave?
Yes, how do I do that?
Just copy paste these two expressions and add them together.
No, this is not going to work, because I'll tell you why this is not going to work. Because this blue line is not essentially what I'm trying to represent to you. Because this is supposed to be a short impulsive forces. I for the sake of the peak observation, I made them in a continuous sine curve.
It's the frequency of the impulsive forces, sir, but not the actual impulsive forces.
Exactly. I mean, this blue graph represents the actual frequency of the impulsive forces, but they are not the actual impulsive forces. We could make it, I mean, with certain amount of talent, we could essentially make those spike graph. Everything is possible, but I do not know how to find that out.
Fourier series, sir, but I'm not experienced.
Yeah, exactly. That's I didn't just want to say that word, but you get my point. So adding them would not essentially give us any fruitful data. It might as well be confusing for some of us. So let's not go there.
Okay, sir, no problem.
বুঝা গেছে?
Ji, sir.
Okay. So did you understand the explanation altogether? We actually spent a lot of time, and the entire class time is gone. But I really enjoyed it. Many of you might not have, but I'm pretty amazed. I feel pretty good.
That's all right.
I'm sorry. This is amazing. I mean, this is good. আচ্ছা, এরপর কোশ্চেনটা দেখি। 13 এ কোনো প্রবলেম?
13 B1.
স্যার
B1
13 আছে।
আচ্ছা দেখতেছি a frictionless trolley of mass m is held on a horizontal surface by means of two similar surface springs each of spring constant k. The springs are attached to fixed points as illustrated in figure 2.1. Okay, when the trolleys are a trolley is in equilibrium, the extension of each spring is e. The trolley is then displaced at a small distance x to the right along the axis of the springs. Both springs remain unextended. Okay,
ইসিটা লাগবে।
acha when the trolley is in equilibrium, the extension of the spring is both trolley, then the trolley is then displaced by some distance to the right along the axis. Both strings remain extended. Acha, okay, so let's make sense of this part of the information first. We have a trolley, we have two springs, identical springs of spring constant k, which is attached over here. And whenever the trolley is equilibrium at the midpoint, the extension of each of these trolley is e. So this is now at an extension of e. This is also at an extension of e, which means this trolley is experiencing ke force to the right and also ke force to the left. Hence the equilibrium. Hence it is stationary. It says the trolley is then displaced a small distance x to the right. So we have moved it to the right along the axis of the springs. Both springs remain extended. It means even when you move this object to the right by x distance, this trolley is still extended. This spring is still extended, which means what? We did not move the trolley by e. We moved the trolley by a length smaller than e. Get this information first. The extension of this trolley was a spring was how much? E, right? If you want to maintain this in this extension state, you cannot make this trolley move to the right by a value of e. You have to make it move less. To keep this trolley to keep this spring in its extended state, we have moved the trolley to the right by distance of x, which would essentially mean e is greater than x. এটুকু আমরা একটু মাথায় রাখি কারণ এটা পরে কাজে লাগবে. So that the magnitude of the force or restraining force on the acting on the trolley is given by F equals to 2kx. Achha, this part is pretty simple. F equals to 2kx এর basic idea হচ্ছে I can as well write over here where এখানে trolley. How much is the force to the right? The force to the right would be k into e minus x. Force on the left should be k into e plus x. Now see if you can make sense out of it. When the trolley was moved to the right by a distance of x, then the right spring has an extension of e minus x, and the left spring has an extension of e plus x. The right spring got less extended, and the left spring got more extended by an amount of x each, right? And this is the formula for Hooke's law. F equals to kx, force into deformation. Deformation to extension or compression, or deformation is equal. So what is your total resultant force? So resultant force equals to the sum of these two. You add these two up. K into e plus x plus k into e minus x. But এখানে plus
sir, but force is a vector quantity, so একটা negative হওয়ার কথা না.
Exactly, we will take করছি.
স্যার মানে মাইনাস হবে কারণ ডিরেকশন ডিফারেন্ট দেখে।
Yep. So এখান থেকে হিসাব করলে আলটিমেটলি তোমার 2kx চলে আসবে. Alright, এরপর কি বলছে? The trolley is then released so that the acceleration of the trolley is given by this expression. F equals to ma. এটা তো প্রবলেম হওয়ার কথা না।
ওইটা পারছি কিন্তু মাইনাস সাইনটা কি আমি অল অফ আ সাডেনই দিয়ে দিব? মানে মাইনাসটা আমি কিভাবে পুট করব? এমনিই দিয়ে দিব? ওয়ার্ডিংটা স্যার বুঝতেছি না। মানে মাইনাস 2kx এর মাইনাসটা স্যার
বলতেছি দাঁড়াও। এই এক্সট্রাকে আচ্ছা দাঁড়াও আচ্ছা, এখানে মাইনাসটা আসার কারণ হচ্ছে this equation that I have written over here, I have considered this direction to be positive. Check this out. এই ফোর্সটাকে কি বসানো হয়েছে? পজিটিভ ফোর্স। এই ফোর্সটাকে বসানো হয়েছে নেগেটিভ ফোর্স, রাইট?
Yes,
Agree?
sir.
আচ্ছা। So when the trolley is on the left side of its position, let's say this was our one block, this is our another block, this is the plane that we have, and the trolley is over currently. Let's say the trolley is over here, with this wheel here is bottom. So we have the right spring and we have the left spring. Left spring is more extended. Okay. So whenever it is away from its equilibrium position, let's say the equilibrium was, let's say, over here. So now the new equilibrium, now the maximum position is over here. So in this case, the resonant force is pulling to the left, but the displacement is essentially what? To the right. Can you see that? The trolley used to be over here. Let me draw the initial position with green. The trolley used to be over here. I'm drawing for the midpoint at equilibrium. We move the trolley to the right by distance of x. So this displacement is to the right. For this direction setup that I used, this is supposed to be negative displacement. In which case the force that is trying to pull the trolley to this original direction, that is supposed to be plus F.
Yes, sir.
So this 2kx that we are getting is a force that is working to the left, right?
Yes, sir.
But the displacement that happened was I mean, this force was available at a displacement of minus x. So we can write that the force available from the springs is this much because of the elastic force. So the trolley would, আচ্ছা এখানে ল্যাঙ্গুয়েজটা হচ্ছে সিম্পল। আমি এটাকে আমি এই প্লাস মাইনাসের কনসেপ্টটা আইডিয়াটুকু বললাম হচ্ছে বোঝানোর জন্য। বাট ইউ ক্যান লেটস সে ইফ ইউ অনলি গো ফর এফ ইকুয়ালস টু, মানে তুমি ওই কোশ্চেন আনসার ডাইরেক্টলি এখান থেকে শুরু করতে পারবা যে because for, I mean, I'm কথাটা বলি না লিখতেছি, because force and displacement are both vector quantities, and in the case of trolley, the displacement and the force experienced by the trolley, they work in opposite direction. Or you can say when the trolley is moved to the right, the force working on the trolley is working in the left direction. Hence, F equals to minus 2kx. Now what I want you to understand, that I'm bringing this minus out of nowhere because in question number 1a they asked us to find out the magnitude. Have a look at this word. See that?
Oh, yes, sir. দেখছি।
So এখানে 2x আসছে আর এখানে তুমি ওই ভেক্টর লজিকটা ইউজ করে এখানে একটা মাইনাস সাইন ইন্ট্রোডিউস করবা। Once you introduce the minus sign, just the math will follow.
আচ্ছা আচ্ছা, থ্যাংক ইউ।
বুঝে গেছে? ঠিক পারছো?
হ্যাঁ স্যার, বাকিটা পেরেছি স্যার। অন্যগুলা কি নেক্সট ক্লাস করতে পারি? মানে আমার একটু যেতে হতো, আর অনেক প্রবলেম আছে আনসলভ।
স্যার নাম্বার সিটা একটু এক্সপ্লেইন করবেন?
এটা
স্যার সি যেটা এতক্ষণ করছিলেন ওটা নাম্বার সি।
আচ্ছা সিটা আলাপ করে তাহলে ছেড়ে দিছি, তোমাদের সমস্যা নাই। Suggest why the trolley in B provides a simple model for the motion of an atom in a crystal. Acha, this is because the motion of atoms in a crystal is held in its stationary position by intermolecular attraction forces. Here the atom bolte amra bolte pari interatomic attraction forces. These forces, I mean, the atoms are stationary in their position, but they can vibrate back and forth. When the intermolecular gap between two atoms becomes smaller, they repel each other. And when the intermolecular gap between two atoms become larger, they attract each other. That's how the intermolecular force works. So what is important that in this case we can see that whenever this trolley is getting closer to the left spring, then it will experience a force to the right. Whenever it will get closer to the right block, then it is going to experience a force to the left, which means I mean, if you consider both of these blocks and this spring, this trolley as 3 individual atoms, they're always going to try to maintain an equal distance. Whenever you are trying to get close, they're going to repel. Whenever you're trying to get away, they're going to attract. Ultimately, trying to keep you in the equilibrium position. That's why this can represent a macro model for the atoms. এক্সামের পরে মার্সিমে ল্যাঙ্গুয়েজ দেখি একটু আমরা এটা কত নম্বর কোশ্চেন ছিল 13 atom held in position by attractive forces. Atom oscillates not just 2 forces or 3D or not 1D, force not perpendicular to x. Any two relevant points, 1 each, max 2.
Sir, force not proportional to x বলতে কি বোঝাচ্ছে? যেমন
এটা মানে হচ্ছে যে আমাদের এখানে আমরা স্প্রিং দিয়ে কাজ করতেছি বলে because we are working with springs over here, the force I mean F equals to 2kx is an equation that we did get, where k is the spring constant of each of the springs. So this is, in this case, the available force that runs with that operates with the oscillating case, that is dependent on the displacement. But for the atom, it might not be.
So it's not entirely proportional, but আমরা just বলতে পারি যে কাছে গেলে রিপেল করে আর দূরে সরতে গেলে তখন অ্যাট্রাক্ট করে।
এক্সাম্পল রিপোর্টটা দেখি আমরা।
আবার এখানে ওরা মেনশন করে নাই রিপালশনটা, তারা জাস্ট অ্যাট্রাকশনটা মেনশন করেছে।
আচ্ছা, এক্সাম্পল রিপোর্টটা দেখো। There are some good suggestions based on the concept that the atoms vibrate and are held in their mean positions by attractive forces. Very few suggested that there would be more than 2 forces acting on an atom in a crystal, or that the the oscillations would be in 3 dimensions. Okay, that's pretty much it.
স্যার
বলো।
ওরা তো সিমিলারিটি বলতে বলছিল, তাহলে এখানে ডিফারেন্সেস দিছে কেন? মানে 3D হবে 1D হবে না, এটা তো মানে অনেকটা ডিফারেন্সেস হয়ে গেল, বাট দ্য কোশ্চেন তো সিমিলারিটি চাচ্ছিল।
I think they asked us to compare. Similarity was specifically, is that the word they used?
মানে ওরা বলছে how this is like a atom.
Suggest why the trolley in B provides a simple model for the motion of an atom in a crystal.
As a 3D হলে তো স্যার atom 3D হবে, 1D হবে না।
এখানে ওরা সিমিলারিটিও বলছে এবং ডিফারেন্স দুটোকে ইউজ করে তারা এক্সপ্লেনেশন দিচ্ছে। So this is a mixed up question. I mean, the question is not essentially clear. Have a look. The word they have used is suggest, not describe and explain.
Atom তো স্যার একটা 3D মডেলের মধ্যে থাকে।
হ্যাঁ, that's true.
আমরা 3D মডেল ইউজ করি না, তো 1D হবে
তো
না।
এখানে 3D এনে তো
the explanation of 3D is not difficult part. I mean, because atom exists in a 3D structure, its oscillation is also going to be 3D, not like a one dimensional or linear movement like the trolley over here. That's what they mentioned. But the question that the student asked is that if we are trying to represent, we are trying to validate this model as a behavior of atom, then we shouldn't we be more concentrating on the similarities of those two things rather than the dissimilarities? That was the question.
স্যার এখানে আমরা যে মডেলটা ইউজ করছি সেটাও 3D না?
না, আমরা এখানে আমাদের এখানে ট্রলির যে অসিলেশন মোশন সেটা তো ওয়ান ডাইমেনশনাল। Trolley is going to move left and right because of the attraction, because of the pull of the different values of the pull of the two springs. Your trolley is not going to move back and forth or out of the page or into the page or up and down. It's only going to move left and right. That's how the system is designed. That's why the motion of this trolley for this given setup is one dimensional, lengthwise only.
স্যার 2 ফোর্সের ব্যাপারটা বুঝলাম না স্যার।
Or 2 forces ব্যাপার হচ্ছে যে in an atom, one atom would not be subjected to only 2 forces, because any single atom in a crystal is not surrounded by only 2 atoms. There are multiple atoms around it, depending on the shape of the crystal structure. You can have tetrahedral, you can have rhombohedral, you can have aro ki jani ase benzene cycle jegulo ase. You can have a lot of different shapes. So your available force would not be essentially coming from only 2 forces. You would have a lot of objects around, and they can provide individual forces. So the number of forces involved can be definitely more than 2. Abes ki boltila?
Sir, it mentioned simple model. That's why it doesn't really matter if this trolley fully doesn't conform to the model of atoms.
Yeah, exactly. So that's what
Just
I'm
a simple
trying to
model.
say. Exactly that.
I think the main point is
This-
just keeping it in the same place, right?
Yes, that's the main part. That by the application of all the forces subjected on the atom, they are going to keep the atom in its equilibrium position, and the vibration happens in 3D space. এই দুটো লাইন লিখলে হয়ে যাবে। বুঝছো?
Sir.
হ্যাঁ স্যার।
Pawan, thank you very much. I'm really sorry to have wasted a lot of time. আমি definitely আগামী ক্লাস খুব early শুরু করব. I'll sleep well. I'll definitely sleep well, and we'll continue from this point onwards. I'm stopping the lecture recording. The lecture is officially over, but I'll be available in the channel for a couple of more minutes. So for those who have to leave, you can leave. For those who have additional question, stick.
Sir,